Welcome to another edition of Green is Good. This is the Wharton IGEL GE Innovation Water Technology edition of Green is Good here in beautiful downtown San Francisco. We're so honored to have with us today Bill Swanson. He's the Water Resources Practice Leader at MWH Global. You can find them at www.mwhglobal.com. Welcome to Green is Good, Bill.
Thank you, John. Great to be here.
Thank you. And I get a little head start on our audience because I got to moderate this wonderful panel which you were on today and hear some of your great thoughts. Before we get talking about your thoughts with regards to water, water reuse, water recycling, and other important water technology issues, can you share a little bit the Bill Swanson story? Give a little bit of background on how you even got here to our listeners and our viewers.
Happy to. So I've been in consulting engineering all of my career, over 30 years, with a primary emphasis on water resources planning and management. What excited me about the field from the very beginning was the intersection of public policy, economics, and engineering technology. My background is engineering, but I'm fascinated mostly by the social policy and the economics of water solutions.
Wow.
So because it's truly the public decision-making model that drives our choices.
That's right.
The engineers can solve any problem given to them, but the public has to accept it in a way that's environmentally sustainable, publicly acceptable, and affordable.
Right.
So our challenge in water resources is really finding those sweet spots, if you will. And rarely is it individual projects. It tends to be complementary solutions that fit together as part of a package.
Gotcha. And so talk a little bit about your practice at MWH Global. What do you exactly do there, and what is the mission of MWH Global?
Well, our mission is to build a better world. It's our tagline. And we are exclusively focused on the water sector in doing that. Anything related to water, we're involved in, from its sourcing, capture, treatment, distribution, collection of wastewater, if you want to call it wastewater.
Yeah.
The development and improvement of, I'm not going to call them wastewater treatment plants, let's call them resource recovery factories, because that's really what they are. We can capture nutrients, water, and energy in what we traditionally call wastewater plants. We're involved in hydropower development and improvements. We're involved in flood planning and land use planning related to that. We're involved in the mining sector. Anything that touches water, MWH is involved.
Around the world?
Globally, yeah.
How long has it been in business?
200 years.
And is it busier than ever before right now?
We're seeing a shift in the marketplace. So in our business, the market tends to fluctuate to some degree between the investments in municipal and government water systems,
right,
and private sector in manufacturing, mining, hydropower development. And we're seeing some shifts, a resurgence, if you will, particularly in the U.S. in the municipal marketplace, where the economic downturn of 2008 really set many ideas into a standstill. And as the recovery has progressed, we've been seeing an uptick. It's really now about to explode.
Gotcha. We're sitting here in California today at this great conference of thought leaders, you being one of them, and I'm honored to be here among all of you. Why did you come to this conference today, Bill? Why now, and why California? Why is this such an important convergence of thought leaders to be talking and messaging around the issues of sustainability, water, technology, and innovation?
I think the biggest driver is the fact that we're in a 4-year, maybe it's a 7-year drought that we're in right now.
Right.
And it's heightened everyone's interest in what can we do now and what decisions should we make now to prevent us finding ourselves in the same situation in the future. Whether it's California, anywhere else in the arid western U.S., parts of the Southeast, or frankly in many other parts of the world, the era of low-cost, high-quality, local water supplies is over. We've developed our water resources to the point now where the next increment of water will come from more sophisticated technologies and more collaborative solutions. So why now is because this drought provides an impetus for these conversations.
Gotcha.
What interests MWH about this is everything I just said a moment ago. Our mission really is to help our clients find not just projects that work, but solutions that work.
Gotcha. Do you feel that we are here, and I know you're from this area locally now, but we're near the hub of innovation, Silicon Valley. And is this where some of the greatest technology is coming out of, or are you borrowing from technologies around the world and helping implement and get those technologies put through systems around the world? And where is the best water technology today stemming from?
Well, I'm not sure I have a good answer on where the best water technology is coming
or
from
some of.
today. But we're not limited. I agree with you. The Silicon Valley is an incredible incubator, if you will, for high technology. But that's not it's not the only place in the world where there's high technology related to water.
Got it.
Water treatment is tends to be a locally driven solution still. Right? Water is a local resource. One of the comments today was that water scarcity is a global problem, but it manifests itself in local situations. I've heard people talk about water as a commodity. I don't subscribe to that.
Okay.
Commodities are goods that can be transferred globally on a common platform.
Right.
There is no global water marketplace because water is too localized in its origin and it's too heavy to move great distances. So what we really are trying to find is the marriage between the local limitations, and they're all different everywhere you go, and the globally available technologies that can be brought to bear. So where the best, I don't know if I have a good answer where the best technologies are, but there's great water treatment technology developments going on around the world.
Gotcha.
We see some of the most innovative applications in underdeveloped nations where necessity is driving solutions that maybe aren't as socially acceptable today in more developed nations.
Let's talk about something that's actually close to us here in San Francisco. San Diego, you're doing some work.
Yeah.
And the Central Valley. Share the tale of two areas in California with some of the greater work that you're doing in San Diego, and also some of the fascinating constructive collaborations that you're working on in the San Joaquin Valley.
Okay. San Diego, right now, we're in the process of what we call the Pure Water Program. San Diego has two competing challenges at the same time. One is, for a large city in the U.S., they're fairly unique in not having full secondary treatment of their wastewater. And so primary treated sewage is being discharged to the Pacific Ocean.
Wow.
It's a violation of the Clean Water Act.
Wow.
At the same time, and it's very costly to modify the plants to accommodate that improved technology. At the same time, San Diego is at the end of pipelines for imported water. Most of their water supply, 85% of it, is imported from either the Bay Delta or from the Colorado River Basin. And it's moved through metropolitan water district systems. Well, by the time it gets to San Diego, it's gone through a lot of pumps and pipes and reservoirs and treatment, and the cost of water is relatively high. So San Diegans face an interesting challenge, right? They have a potential cost for additional treatment of their wastewater, and they have potential great cost for the next increment of water supply. What the Pure Water Program does is it combines these two needs into a singular solution, where some of the water that would be discharged to the ocean from the treatment plant that will instead be treated using very high quality and high technology treatment methods and reintroduced into the water supply system, saving the treatment plant improvement costs and providing a water supply to the city at the same time.
And how long, when you create solutions like this and fascinating collaborative solutions like this, how long is the process going to take to get them on board with this and get the solution implemented so it really solves the problem?
Well, the drought, again, is the motivator.
Yeah.
In a period of abundant water supply, these types of solutions are very difficult to move forward. But when we're faced with the crisis of limited water supply, and we don't know how long this drought's going to last, it motivates activity. And so the plan for the Pure Water Program is that by 2035, we would have 83 MGD, million gallons per day, in place, with the first increment, about 30 of that by 2023, or maybe even as early as 2021. So we're talking 6 to 8 years of seeing a project go from the concept we're talking about today through permitting, piloting, permitting, design, and construction.
What percentage of the problem does that solve in San Diego area?
I think around 25% or so.
By 2023 or the 2035?
2035.
which is great.
It's great amount, yeah.
That's, talk a little bit about, you have great experience and years of work in the San Joaquin Valley,
Yeah.
which of course is challenged because of the ag stress and everything else. Share a little bit about your experiences there and how you're creating solutions there as well.
So San Joaquin Valley has gone through what I'd call a series of seismic shifts when it comes to water. Think back 40 years ago, there was more water supply available that even during relatively dry periods, the farmers would receive a pretty high allocation of water.
Right.
But over time, our social priorities have changed. And we've recognized that the large water projects that we have caused cumulative ecological damages, and we're trying to reconcile that largely through the allocation of water from those projects back to the environment. So that's reduced the available water supply.
Wow.
At the same time, so that's reduced how much water the farmers can get, but many of them still have to pay for the projects. So just like conservation tends to increase urban water rates,
Right.
the reduction of supply increases agricultural water rates in the same way. So what the farmers have been forced to do then is say, well, let's find ways to make the use of our water more economically appealing. So they've shifted from some of the lower value annual crops to higher value permanent crops, but that's put a hard demand on water that year in, year out, there's a need for water for agriculture.
Gotcha.
Let me add to this. Last year, the state of California legislature enacted first in time legislation to regulate the groundwater in the state of California. And it mandates that groundwater basins develop and implement plans that will result in groundwater sustainability. One of the solutions that the farmers have turned to in the past 20 or 30 years because of water shortages is increased groundwater withdrawals. That's led to groundwater overdraft and in some areas land sinking. So we have these forces all combining to force the irrigators to think differently, and they're truly beginning to. They always have worked relatively collaboratively, and we're seeing an acceleration of that, where areas that would sometimes be in conflict with one another are now beginning to work more collaboratively for common solutions and moving water across the San Joaquin Valley east to west. We're seeing opportunities for using water that would otherwise have been considered too impaired for use. For example, produced water from oil field wells. And when you pump oil out of the ground, it comes with water. And when that oil and water can be separated, then there's a quantity of water that's available for something. Historically, the oil companies just dispose of it as waste. It's now being looked at as a resource.
For ag?
For ag, yeah.
Really? That's fascinating. So, given where we are right now with regards to what you know and the global opportunities, plus also the local opportunities, technology makes you hopeful for the solutions of our water crisis here in California?
Absolutely it does, yeah. Technology and collaboration.
And collaboration.
As I see it, the availability of technology today provides solutions that may have not existed several decades ago.
Okay.
The advanced treatment capabilities that we have today that are deployable allow us to tap water resources that in the past would be considered untouchable or treated or classified as waste. So now we have the opportunity to convert what previously was a waste product into a true resource.
Is the crisis create then, as you say, the social and political will to help then deploy these technologies?
It does, yeah. And the reality that there's a limited amount of water available to us.
Yeah.
The growth in the future will not be supported by a proportional increase in water supply because there simply isn't additional water supply available to meet the future demands. The emphasis must shift to how we can be more efficient in using the water we have and more greater conservation, if that's the right term, about what we would previously consider to be a waste.
Gotcha. Well, I'm going to leave you, Bill, for the final few words and thoughts on water technology and today's conference for our listeners and our viewers out there as we have to sign off today. But I want you to share some of your final thoughts with our viewers.
Okay. Well, one of the thoughts I would pass along is that where we are today in water resources is a new normal. We're seeing the effects of climate change. We're seeing the effects of extreme events that are perhaps more extreme than we've seen in the past. The infrastructure we have today wasn't designed with these events in mind. So what that means is as we start thinking about packaging solutions in the future. We need to shift away from thinking about a replication of the past as an indication of the future, and instead do our planning around the construct of risk. And so we start thinking about, well, what are the risks that the climate will change in a variety of ways? What are the risks that the demand for water might be different than we think, either climate-driven or population or industrial-driven? What are the risks that regulatory requirements, whether they be water quality or ecosystem, could impose further restraints on how we use water? And what are the risks of catastrophic failure of our infrastructure? As we make choices in the future about the combination of sources and supplies of water in our portfolio, it's this risk analysis that needs to be thought through to arrive at not just the best economic solution, but the best resilient and durable solution.
That's perfect. And thank you, Bill, for your time today. And thank you to our listeners and our viewers out there. This was John Shigarian at the Wharton IGEL GE Water Innovation Technology Conference here in beautiful downtown San Francisco. I'm joined today by Bill Swanson from MWH Global. To learn more about Bill's great work with his colleagues, please go to www.mwhglobal.com. Bill, thanks for your great work. Thanks for making the world a better place. Thanks. You are truly living proof that green is good.
I appreciate that. Thank you.
Thank you so much. For our listeners and viewers out there, thanks for watching this edition of Green is Good. We'll see you next time at Green is Good. Have a great day.